Okay, as soon as I finished that last video, I just thought of something cool. I mean, the answer we came out to, if you haven't watched the one on neon in a container, 15-liter container, yeah, this is pretty cold, 220 K, but it's not super cold. In fact, if you look at things like the melting point, the boiling point, you can see that uh, to go to a solid, you're going to have to get colder than 248 below Celsius, or 24.56 Kelvin, and we're nowhere close to that, right? But what if we wanted to? Well, how do we figure out what kind of pressure this neon would be under to get to that temperature? That's kind of a cool problem to solve, right? So now I'm going to come over here and I'm going to say I can use the same equation, right? Uh, I've got a lot of the information already, right? I've got this here, that's the number of moles, right? I've got the temperature. Okay, yeah, that's going to be my starting point. Okay, and pressure, volume. Let's say I want to adjust the volume. Okay, so I'm going to push it down, and as this goes down, what's my volume got to be? How much do I have to compress this? And maybe later, if I get really ambitious, I decide how much work would it take to do that. So let's do first things first. We're going to come back to our same equation, right? Uh, PV equals nRT. That's a little off the screen, but I'm going to force it off the screen completely now. PV equals nRT. Now I can look at that and I can say, well, what can I rearrange? What do I want to know? Okay, well, what I want to know is the volume, right? Okay, well, I had my original volume, but I'm worried about changing it now. So let's say I'm gonna, oh wait, this is easier than I thought, but I want to derive it from this anyway. Really what I'm asking is volume over temperature equals, well, that's one way I could look at it. How cold would it get, right? Yeah, that's exactly what I want. Never mind, forget deriving it. Let's do it the easy way, right? Okay, so let's look at this. I've got a volume here of 15 liters. And right now it's at 220 K. I know this is a little sloppy because I've done my rounding already, but I don't want to go back. I just want to get the principle. So I come over here and I say 15 liters at 220 K is the same as, and I said that my where neon would turn solid is really cool, 24.56 K. 24.56 K. Talk about frostbite, right? Okay. I probably should have moved that down, but here, you know what I mean. So what's the volume going to be? Okay, so that volume is going to be V2. Let's do the math. This is easy now, right? I just say over here, calculator. All right, calculator. Hi, calculator. I love my HP. It's such a nice looking good boy. Okay, so okay, 15 liters, right? Is where I started out, and 24.56 K Kelvin, not 1,000, right? Multiply that, and I divide it by 220 K Kelvin, right? Let's just not get confused here. And I'm dividing because I cross multiply this, right? This times this divided by this. Okay, so 220, oops, background, yeah, okay. Yeah, that's it. Okay. Wow. Huh. Okay. Well, it's not as much smaller as I thought it would be, but it looks like this would come down to a volume way down here. Here, maybe I can move my dot. No, maybe I cannot because it's locked. Okay. Anyway, so my final volume would be 1.67. Let's get that right here. Oh boy. Okay. 1.67 liters for 350 grams of neon, starting out at 220 Kelvin to get it down to be solid neon. All right, now let's, we could do the same thing. We could say, well, We can run it out the other way and say, what happens when I bring this up to room temperature? What kind of pressure am I going to be dealing with, right? That could be an interesting question. So, gosh, making up your own homework is so much cooler. Okay, so let's do this. Okay, I've got rhythm. No, I don't. Okay, blah, blah, blah. What am I asking then? I want to know what happens if I take this volume, that 15 liters that we started out with, okay, 15 liters, divided by the temperature, which we said would be 220 K. And I hope this will make sense what I'm doing here in just a minute. This is just V over T, right? V over, whose is that? V over T, that's Charles' law, right? So that is going to be equal to, well, okay, I could show a volume. That's probably not the best rule for this. So let's back out of that for a sec. What I would have found from that is a much bigger volume to support at a room temperature. So let's not do that. I'm going to say that PV equals nRT, right? And from PV equals nRT, I'm going to say, how about, let's see, I want to know what the pressure is going to be like when I go to room temperature, right? So I can multiply this whole thing by 1 over V, and this whole thing over 1 over blah, blah, blah. As long as I'm writing, it doesn't matter, my brain melts down, right? So pressure, oh, that's a bad choice of color, come on, man. Okay, so the pressure, here this suggests pressure, the pressure, new pressure anyway, is going to be equal to nRT over, well, we multiplied by 1 over V, so that's that, right? All right, so we start plugging things in. The number, well, we know what the number was from our previous calculations. That was up here. That was, oh yeah, 17.3439 moles, okay? Just come back, computer. Man, seriously need an upgrade, man. Wait for it, wait for it. I probably have too much stuff open too. Okay, so here we go. 17. Now I forgot what the number was. 7. Crap. Oh, it's like almost in complete lockdown. What's going on? You know what's going on? I know what's going on. I was uploading the last video at the same time I'm recording this one. It's like, I think my computer is Hercules or something. Maybe it'll help if I do this. Okay, now I can see it all at once. So I've got, I've got to take a nap is what I'm going to do, I'll tell you what. Okay, so pressure is going to be equal to the number of molecules, and we're doing that in moles. We're saying 17, but I could do that in just strict number of molecules if I were a masochist. 17.3439 moles, right? And I can zoom back in because I've got that, times R, and we said the R was 0.08206. Go away, calculator. Thanks for playing. Okay, and you can come back, don't be sad. And here we go. This is, oh, crap, I lost my place. Where was I? Oh, T, temperature. The temperature, what's room temperature? I don't know. Should we just say like 22 Celsius? So let's just say 273 plus 22. That's a cozy temperature, right? Something like that. 5, says the guy who lived his whole life in Fahrenheit, 295, okay? Did I do that right? Yes, 295. 295 Kelvin is the temperature. And then I put that all over, waiting for the computer to catch up. I might be in for a reboot here pretty soon. Divided by, and I'm not even talking about the computer, the volume of 15 liters. Is that right? Yes, 15 liters. Okay, now we can do some arithmetic. Okay. So I've got my 1.6738, blah, blah, right, times 0.08. I left the units on this because I'm getting lazy and this is getting long. 08 206. Oh, wait. I don't know what that top number is. Okay. Better not use it. 17.3439. That's the number of molecules, right, in moles, times, and then 295 is the temperature in Kelvin, and I divide that by my sloppily written 15 liters. Divide. All right, that leaves us with a pressure of 28.0 atmospheres. That's pretty intense. You know, if you wanted to do a quick conversion on that, let's just see what that would be. This is where I'm going to get lazy. I want to see if Google can do this. If not, we'll do it the hard way, I guess. Well, yeah. So we'll say 28 ATMs in PSI. So if you can imagine, to bring that canister, a 15-liter canister, inside to room temperature from where it was.
Avast virus database has been updated.
Thanks, Avast. Okay. Anyway, so 411 pounds per square inch. That would probably crush you, and it probably would not stay in the container. So I don't recommend trying this unless you know, you're a professional who has a really strong container. Thanks. Bye.